This question says a golf ball is at rest at the point A on horizontal ground. The ball is hit and initially moves at an angle alpha to the ground. The ball first hits the ground at the point B, where AB is equal to 120 meters as shown in figure 3. The motion of the ball is modeled as that of a particle moving freely under gravity whose initial speed is u meters per second. Using this model, part A showed that u squared sine alpha cos alpha is equal to 588. So the first thing to do for any projectiles question is to find the horizontal and vertical components of motion. So we know that the horizontal displacement is 120, so we can put our S in horizontal as 120 meters. We know that u is a diagonal vector, so we need to find the horizontal and vertical components of that vector. So using trigonometry, we know that the horizontal component is going to be u cosine alpha, and the vertical component is going to be u sine alpha. So we can put that into our horizontal component, u cosine alpha. We know that the acceleration is a vertical force. So the horizontal component of our acceleration will be 0 meters per second. Moving on to the vertical, we know that the displacement in the vertical will be 0. Our initial velocity u is going to be u sine alpha. Our ball is being hit and moves against gravity, so our acceleration will be minus 9.8. And we know that the time that this ball takes for it to reach from A to B will be the same time in the horizontal and the vertical components, so we can just put that as a capital T, because as of now, we do not know the value of that. So using SUVAT formulae, S is equal to ut plus a half at squared, we're first going to substitute our horizontal components. So my S is 120, my U is u cosine alpha, and my T is a capital T. Because A is 0, that means the whole of that part of the equation is going to be 0. Using the same formula for my vertical components, I will put 0 is equal to u sine alpha times T plus a half minus 9.8 multiplied by T squared. Using the first equation that I've got, we can make T the subject by dividing both sides by u cosine alpha. So that makes T equal to 120 over u cosine alpha. We have now got an equation for our T, and we can substitute our T into the second equation that we have. So we can write this as 0 is equal to u sine alpha. Instead of T now, we can put 120 over u cosine alpha plus a half times negative 9.8 and 120 over u cosine alpha squared. We can now simplify this by cancelling the u's in the first part of that equation, and we can rewrite this as 0 is equal to 120 sine alpha over cosine alpha. A half times negative 9.8 is minus 4.9, and we can square the 120 to give us 14,400 over u squared cosine alpha squared. We can then multiply both of these terms by cosine alpha to simplify it. So in the first part, our cosine alpha will disappear from the denominator. And in my second part of the equation, my cosine squared alpha will be just cosine alpha. We can then multiply all through by u squared cosine alpha to get rid of the denominator. So we will now have 120 u squared sine alpha cosine alpha. And we can multiply the 4.9 by 14,400. That will give us 70,560. Our question says that we need to show that u squared sine alpha cosine alpha is equal to 588. So now we just need to try and make u squared sine alpha cosine alpha the subject. So we will move our 70,560 to the other side, and we can divide both sides by 120. which will now give us 588, is equal to u squared sine alpha cosine alpha as required. So the next part of the question says that the ball reaches a maximum height of 10 meters above the ground. Show that u squared is equal to 1960. We've been told that the maximum height is 10 meters. We also know that at the maximum height, our velocity is always going to be equal to 0. We therefore have to write new values for our suvat for the vertical motion. Our s is now going to be 10. Our u remains u sine alpha. Our v is 0 because it is at maximum height, and our acceleration is negative 9.8. Using our suvat formulae, which are given in the formula booklet, in order to show that u squared is equal to 1960, we first need to find the value of our alpha. In order to do that, we need to use a formula that does not have t, and that is v squared is equal to u squared plus 2as. Subbing in our values, we can work that out as 0 is equal to u squared sine squared alpha minus 196. Making u squared sine alpha squared the subject, that is equal to 196. In part A, we have shown that u squared sine alpha cosine alpha is equal to 588. We therefore now have two equations, and we can divide equation 1 by 2, giving us u squared sine squared alpha divided by u squared cosine alpha sine alpha is equal to 196 over 588. Our u squareds can cancel, and we can cancel 1 squared in the sine with the sine alpha in the denominator. Using our trig identities, we know that sine alpha over cosine alpha is tan alpha, and we can simplify 196 over 588 to 1 over 3. We therefore now have the values of the opposite and adjacent side of a right-angled triangle with angle alpha. And in order to find the hypotenuse, we can use Pythagoras theory. 3 squared is 9, 1 squared is 1. This therefore gives us root 10. Our hypotenuse is therefore root 10. And using this, we can now write values for our sine alpha, which will be opposite over hypotenuse, which is 1 over root 10, and cosine alpha, which will be adjacent over hypotenuse, which will be 3 over root 10. Again, using what we showed in part A, u squared cosine alpha sine alpha is equal to 588. We can now substitute in the values for our alpha. So u squared 3 over root 10 multiplied by 1 over root 10 is equal to 588. This gives us 3u squared over 10 is equal to 588. If we multiply both sides by 10 and divide by 3, this will give us u squared is equal to 1960 as required. The question then says, in a refinement to the model, the effect of air resistance is included. The motion of the ball from A to B is now modelled as that of a particle whose initial speed is v meters per second. This refined model is used to calculate a value for v. Part C asks us to state which is greater, u or v, giving a reason for our answer. So for part C, because air resistance is involved, that means that v will be higher. Part D says state one further refinement to the model that would make the model realistic. For part D, we can say that in real life, the ball is not actually a particle. Therefore, we can say the ball's size, shape, or dimensions can be included in the question.